Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So today we'll be seeing week 6 summary. Have you guys gone through week 6 lecture? Did you guys go through week 6 lecture videos?
No, ma'am.
No, ma'am, not yet.
Okay. No problem. So yeah, I will take week 6 summary today. Then if you go through the videos, I hope it will be little easier for you. So yeah, we will start today's session. So today we will be basically seeing about a basic of amplifiers. Then we will also see power conventions. Then we will also be seeing RC step response. So these are the three topics which we will be seeing in week 6. Okay?
Okay, ma'am.
Yeah. So have you guys heard the term amplifier?
Yes, ma'am. Ma'am, I think it increases the
Yes.
frequency, no?
Uh, is it the frequency or the amplitude?
Oh, sorry, amplitude is.
Yeah.
Amplitude, ma'am.
Yes. So basically, in the last week, we would have seen about the mixer, right? Mixer circuits.
Yes, ma'am.
So if there are one or more input voltages, V1, V2, going inside a mixer circuit, the output will be in the form of AV1 plus BV2, right?
Yes, ma'am.
And this A and B will, what is the range of this A and B? Will it be greater than 1 or less than 1?
Ma'am, less than one.
Yeah, it will be less than equal to 1. So what does it says is, this Vx will contain only a part of this V1 and V2, right?
Yes,
If
ma'am.
V1 is 5 volts and V2 is 7 volts, whatever the value of A and B, since it is between 0 to 1, this Vx will contain only, uh, it will, the Vx will always contains a part of V1 which is always less than 5 volts and V2 which is always less than 7 volts, right?
Yes, ma'am.
Yeah. So, so basically what we are going to know is, after this mixer circuit, we are not always increasing the amplitude of the signal. It's always reduced, right? Either it reduces or remains the same. So let this V1 be the output of some mic. Let this V2 be the output of some musical instrument like guitar, for example.
Ma'am, I think your voice is breaking.
Yes, ma'am. After, for example, there is no word.
Yes, ma'am. You're not audible.
make the input voltage into a higher voltage signal, we need this
Ma'am, your
amplifier.
voice.
Is
Your
it breaking?
Ma'am,
ma'am,
now it is audible, but before it breaked.
yes, ma'am. Since
Okay.
2 minutes, you was not audible.
Yes, ma'am.
Oh, okay. So yeah, what I was saying is, so uh, the voltage signal from different instruments, it may be guitar or from mic, all the signal will be entering the mixer to get the Vx, right? Now, before this Vx reaches the speaker, this speaker can be of different types, right? It can be like a small speaker or a large speaker, like used to,
Ma'am, what?
depending on the
This,
size of.
ma'am, VX goes where? In amplifier.
Yes, the Vx will go into amplifier. So as to amplify the signal, we have to make this signal will be small, right? So our aim is to have a larger signal so that it will be capable of this speaker.
Okay, ma'am.
So in order to change the small signal with a small amplitude into a signal with a large amplitude, we need this amplifier. So that's why we are going to learn about amplifier in this circuit. Also, we have to note, after amplifier, the signal will not go directly into speaker. There are many parts that will come in between, that which you will be seeing, such like filters, to filter out the noises in the circuit for that and all. Okay, I told you just to make you realize what is the importance of amplifier. It's just to increase the amplitude of a certain signal, we use amplifiers. Okay.
Okay.
So basically, there are two types of amplifiers. One is non-inverting amplifier. And another one is inverting amplifier. So we will see these two types of amplifier. So this is a representation of a basic amplifier. So in this week, we will be just seeing a very basics related to amplifiers. Okay. And when you enter the next course like EEC and further courses, you will be learning more and more details about these amplifiers, about the non-inverting amplifiers and inverting amplifiers. Okay.
So, ma'am, before you showed like for what purpose it is used.
Yes.
Okay.
So if I have an input signal B in of t, once it goes inside the amplifier, it comes out as B out of t. So let this amplifier has a multiplication factor, or we call it as gain. So that my formula will become B out of t is equal to A times of B in of t. So if I say there is an amplifier whose gain is 10 and my
Then
input,
this is
let me say
non-inverting.
it's a
Not
non-inverting
sure.
amplifier.
Okay.
Yes. So if my input is some 5 volts, or maybe I will take it as 5 millivolts. What will my output?
50 millivolts.
Yeah, it's 10 into 5 milli, it's equal to 50 millivolts. So this is a representation of a simple non-inverting amplifier. So if I have my input signal as a sine wave, and whose amplitude is, whose peak voltage is 5 millivolt, its frequency, let me say it as 1 hertz. If I am sending it through the same amplifier, what will be my output be? It will be
Then
the same.
output will 50 millivolt amplitude.
Yes. The output will be the same sine wave, but its amplitude will be multiplied by 10. So my peak Vm will be equal to 50 millivolts, right? So this is a function of this amplifier.
Yes, ma'am.
So this factor A, it will be a function of resistors R1 and R2. because this amplifier internally it will be made of resistors in certain arrangement. So this gain A is a function of R1 and R2. Okay, and this A can be adjusted by varying the values of R1 and R2.
And basically, this multiplication factor is because of a function of R1 and R2.
Yeah, can you please say it again?
Ma'am, A means the multiplication factor, no?
It's a multiplication factor, or you can say it is an amplification factor.
Okay.
Amplification factor. And if you see this formula, I can say A is equal to V out of T divided by V in of T, right? Output divided by input. What is that? That's the gain, right? So we can
Okay.
call A as gain also. Gain or amplification factor.
Okay, ma'am.
So these are the things you have to know about the non-inverting amplifier. For non-inverting amplifier, the gain is always a positive value. Okay. So whatever my input is, it is multiplied by the amplification factor. Then I will get my output. So V of T is equal to A into V in of T. So if I give a sine wave through the non-inverting amplifier, my output will be the sine wave with an increased amplitude, right?
Yes, ma'am.
Depending on A. Now we will go to inverting amplifier. Okay, till now we saw non-inverting amplifier. Now we will be seeing the inverting amplifier. So this has a gain, and here also there is an input V in of T, and it has the output VO of T. And the difference between non-inverting and inverting amplifier is the gain is a negative value.
So basically, rather gaining it reduces.
No, it gains in the opposite direction.
Oh.
Let me take in the see. Let me take the same sine wave. So it is 5 millivolts, right? This is 1 second. This is my V in of T. This is my VO of T output. This is like here also I am taking A is equal to 10. So here it is a negative value, no? So my V out of T. So initially it is 0. So 0 into amplification factor is still 0. The next point I will take it as 5 millivolt. So my V in of T is 5 millivolt. My A is minus 10. What will be my V naught of T?
Minus 50 millivolt. Basically 50
Yes.
millivolt in negative direction.
Negative,
So when
yes.
the graph will be inverted.
Yes, exactly. The graph will be inverted. So this is the, what is the phase difference between the input and output?
$50 millivolt.
Minus 45.
You have to,
Ma'am,
is it
No,
minus 45?
55. 55.
No, phase difference in terms of degree.
180 degree.
Yeah, yes, it's 180 degree, yes. So it is 180 degree out of phase with each other, right?
Ma'am, how?
yes,
Yes.
ma'am.
See, 0, 0. This is sine wave, right? At pi by 2, it will be 1. At pi, it will be 0. Then at 2 pi, it will be,
180.
yeah, at 180, it is going down, right?
Okay, ma'am. Okay.
Phase difference between inverting and non-inverting, or positive half cycle or negative half cycle.
Can you please repeat?
Phase difference is means the difference between the positive half cycle and a negative half cycle. covered
No,
by.
I'm asking the phase difference between the input and the output.
Okay.
So if I draw in the same graph, see, this is for non-inverting amplifier. So this is a sine wave, 5 millivolt. If you give it under non-inverting amplifier, I'll get a sine wave like this, right? Only my amplitude changes. So this I'll call it as in phase. They are in same phase, right?
So ma'am, for this phase difference will be 0.
Yeah, phase difference is 0.
Okay. And if opposes, like it started from my negative, then it is
Yes.
it forms the sine wave of 180 degree line.
So this
Like
is
this.
my output. Okay, sorry. So this is my input. This is for inverting amplifier. My output will be like this, right? So this is my input and this is my output. If you see, at 90 degree it is plus 5 millivolt. Whereas at the same pi by 2, the output is minus 50 millivolt.
Yes.
That is the, if you see the second one, it actually starts at here, right?
Yes.
At minus pi by 2, minus pi.
So what we call that wave? It starts from -5.
That is also a sine wave, but it has been shifted sine wave.
Okay.
See, this
No.
is my
And
input
what is
signal.
the difference between the inverting and non-inverting wave? Like.
Okay, you want to know the difference between the inverting and non-inverting amplifier, right?
Yes. Yes. Yes.
Yeah, this is a difference. The non-inverting amplifier, the output will be in phase with the input, whereas in the inverting amplifier, the output will be out of phase. That it will be 180 degree phase shifted from the input.
Okay.
So this is my output, right? But if you see, this is a wave that is starting like this. So this much difference is there between the output and the input.
Yes.
What is this difference? This is pi, right?
Yes.
This is 0, this is pi. This much difference is there. So that we call it as a 180 degree phase difference. Do anyone
Okay.
have in this why it is 180 degree? Or now, this is not the output of the inverting or not inverting. This is just to help you understand what is the phase difference. I will give you one question and you have to find the phase difference between these two waveforms. Okay. So this is my wave V1 and this is another wave.
Draw
So
with
this
the
is
different
0.
color.
Okay, you want me to draw with different color? Yeah, that's also a nice, good idea. So this is another wave. The black one is V1 and the red one is V2. And so this is 0 at pi by 2. This is pi. This is 3 pi by 2. This is pi and so on. So what is the phase difference between the two waves? How will you find it?
Ma'am, 90 degrees because
Yes.
Yes,
Because,
ma'am.
it lies in the center of that wave V1,
yes.
V2.
You are right. If you extend this wave, no, it will be reaching 0 at minus pi by 2.
Yes.
Right?
Yes.
So,
Difference
phase
between
difference
different
between
origins.
0 minus of minus pi by 2, which is equal to pi by 2, which is 90 degree. Right?
Yes.
Yes, ma'am.
If I give it for the same inverting amplifier, now you are able to understand, right?
Here is a phase difference of 180 degree.
Yes. So if I extend it, it will reach 0 at -5. My V1 signal is starting at 0. My V2 signal is starting at -5. The phase difference is 0 of 0 minus is equal to 5, which is equal to 180 degree.
Yes.
Do anyone have any doubt in this? Yeah, no doubts, right? So in
Yes,
short,
ma'am.
amplifier is for amplifying the signal. There are two types of amplifier. One is non-inverting amplifier and another one is inverting amplifier. For both, VO of t is equal to A into V in of t. In non-inverting amplifier, A is positive, gain is positive, whereas in inverting amplifier, the gain is negative. Right? In non-inverting
Yes.
amplifier, V in of t and VO of t are in phase. Whereas in inverting amplifier, V in of t and VO of t out of
Are
phase.
in
Of
yes.
phase.
So these are the things you have to keep in mind. So these are very basics. In this course ESTC, we are not going much into non-inverting and inverting. This is to give you a basic idea that there is an amplifier which exists and there are two types, non-inverting and inverting, and these are the characteristics of that amplifiers. Now, so this is the amplifier,
Ma'am,
and
can you
here I
little
have,
bit slow?
yes,
Okay. Thank you.
okay. So this is VO of t. And also, we are not saying anything what this device is made of. What are the components inside this device? For now, it is just a black box to you. I'm just telling there is a black box like an amplifier. Inside you give an input and other side you take the output. And this have only one parameter gain. And this gain depends on the values of some resistors. These are all which you have to remember for now. Now, this amplifier is supplied by two DC supply. One is VDD, another one is VSS. This is some positive value and this is some negative value. Okay.
Yes.
And my VO of t will be always lesser than this VDD and VSS. Okay.
Yes.
Ma'am, this is non-inverting, inverting, or both?
Both. For both.
Okay.
Ma'am, what is the VSS here?
VSS is a DC power supply given at the negative side.
Okay.
So if I say this is plus 5 volt, this is minus 5 volt, this is my amplifier. My V in of t is some 2 millivolts, and my what will be my V out of t if my gain is 10?
20
Uh,
millivolts.
20. Yes.
Yeah, it will
20.
be 20 millivolts. If my V in of t is 2 volts, what will be my V out of t?
20.
20 volt.
But ma'am, it can't be greater
But
than
it
5
can't be
volts.
20 volts. Yes, right. It can't be. So you will not be actually reaching this 20 volts. It will always be some value less than plus 5 volts and minus 5 volts.
Why, ma'am?
Because see, this device is supplying is supplied by this DC source. If my input is having some energy, okay,
Okay.
and this also will give some energy. If this is giving plus 5 volt and this is also giving some energy equivalent to 2 volt, you can't expect 20 volts, right? The device can't generate some voltage by itself.
Okay. But
This DC
when
supply
we
is
give,
providing that energy.
okay,
So
our
my
in,
energy,
huh. Okay.
of the output will always be less than energy of the DC supply plus energy of the input.
Okay. In above case, ma'am, when we use a 2 millivolts, there are 5 volt is greater. That's why it is possible to give a
Yes.
greater
Mm.
20 millivolts. Okay.
Yes. If I am giving 2 volts, for example, this is my input signal I am giving. Okay.
Yes.
What happens to the output in this device is at 5 volts, the signal will be clipped like this. Because it will not be produce the voltage above that. Okay.
Yes.
So this clipping, we call it as clipping phenomenon.
We give a 12
What is
volt,
clipping
it can't
phenomenon?
be. And what we give, ma'am? 5 volt signals.
5 volts is a DC supply, yes. So what is clipping phenomenon? If there is an amplifier supplied by some VDD VSS and my input is of some range and my output is of some range. So if this is plus 5 volt and VSS is minus 5 volt, if my V input is 2 volts, output I will not be getting as 20. If the gain is 10, I will not be getting 20 volts. So this signal is my input, 2 volts. What I thought I will get is 20 volts. But actually what I'm getting is some clipped signal which is less than 5 volts. So I will be getting some signal which is clipped. So the way how we are getting this clipped signal, this phenomenon we call it as clipping phenomenon. Okay.
Okay. It does not cover that circular path or curve path because it is less than that 20 volts. That's why its wave.
The amplifier is supplied by whatever VDD VSS, the output depends on that. Okay.
Yeah, that's why, ma'am, the wave is not completed like a curve upwards.
Yes.
Okay.
It is just clipped.
Also, I'm like 5 plus 20 millivolts is greater than 20 millivolts, but 5 plus 2 is 7. 7 is like less than 20. So energy in should be greater than energy out.
Yes.
So like that
Yes.
explain.
So whatever my E out energy I have, this energy is provided by the input signal plus this EDC. And due to the circuit elements, there might be some losses. Reducing it, I will get the remaining energy in the E out. Okay.
Okay.
Yeah. So first part is amplifier that we have completed. So you have learned what is amplifier, what is inverting amplifier, non-inverting amplifier, the power supply to the amplifier, the power supply in the term that the VSS and VDD. Then we saw about the clipping phenomenon. We also saw about the energy in the amplifier, right? Do anyone have
Also,
any
I'm
doubt
like
in these topics? Yes,
if we
also
are getting 20 volt in the output, so
Hmm.
but we are only providing 7 volt. So suddenly like we have 13 volt extra coming from nowhere. So that should not be like possible. Like
we are not getting 20
Yeah,
volts here, right?
it
yeah,
breaks the
matlab,
energy conservation law. Like that.
yeah, I'm saying that should
Oh,
be
that's
possible.
it.
So it cannot be 20 volt because of that.
Yes, because yes, right. So next we will be going to another one important topic, that is power conversion.
Ma'am, what is energy out? Can you again tell?
So energy out is nothing but the output signal will have some energy, no? That is I termed it as E out. The input signal will have some energy, that is E in. And the energy provided by this VDD, that is EDC.
Okay, ma'am. By conservation of energy. Okay.
Yes. And what is active element and what is passive element?
Yeah, passive elements which absorb the power and passive elements that delivers the power. Like a battery
Yes,
is
active
a
elements absorbs power, passive elements delivers power. Right. Yeah, battery. What about battery? You were saying something about battery, right?
passive element, and resistors and capacitors like a active element.
RLC or active elements. What about voltage source?
Passive.
No, it can be active or passive, but generally voltage sources provide energy. So we will be putting it under passive elements. But battery is a voltage source, right?
Yeah, it absorbs battery when charging and delivers also.
Yeah.
That's why it is
Yes.
exception like of thing.
While charging, it absorbs power. So it comes under active element and passive element. So there is no definite rule that a voltage source has to be a passive element. It can also absorb energy. Okay.
Okay.
But generally, voltage sources and current sources, we give it as an example for passive elements, because generally when we put a voltage source or current source in a circuit, we use energy or power.
Okay.
So these are the two types of elements. And yeah.
Yeah, professor, tell with that graph.
Ma'am,
I don't understand that using the quadrants.
Resistor, right? Okay, yeah. Yeah, that one, yeah. We saw about the VA characteristics of a resistor, right?
well, in many cases, when capacitor is charged, then it also delivers power.
Capacitors deliver power, but it will not create power out of itself, right? First, the capacitor has to be connected to a voltage source. Once it is connected, it gets charged. Only the stored energy is only delivered out. So it is not a passive element.
Battery is
Well,
also
this
same
scenario
like
happens also in battery.
battery. Yes.
This also happens with battery.
No, capacitor comes under charging and discharging. That is separate from battery.
Okay.
Charging and discharging is not similar to that. So capacitor has separate principles actually. The thing is, battery is supposed to have infinite charge, an ideal battery. It is supposed to provide current continuously also, but capacitor is not the same case. It instantly delivers out the current stored in it.
In milliseconds like that.
Mm. That depends on the way how we design our circuit.
Yes.
Are you able to understand why capacitor is not an
Yes,
passive
ma'am,
element?
because it instantly charge and instantly release. The battery
Yes.
stores for a long time.
Yes. So about the VA characteristics of resistor, we will come to that. Before that, we will learn a few about absorbing power and delivering power.
Yes. Ma'am, I also did not understand that VI characteristics. Always sir and instructor used to
Okay.
explain us VI characteristics, but I did not understand that why it is straight line and
Okay, yeah, I'll come to that. Okay.
okay.
Yeah. So resistors, inductors, and capacitors always absorb power. And okay, if there is a voltage source V and the current is coming out of it, is it delivering power or absorbing power?
Delivering, ma'am.
Delivering.
So normal convention is absorbing power, we'll take it as a positive value, and delivering power, we'll take it as a negative value. Okay.
Yes.
So since this is delivering, we'll take it as a positive. If there is a voltage source and the current is entering the voltage source V, what is it?
Negative, ma'am.
Yeah, it is absorbing power.
Yes.
Oh, sorry. What I said, absorbing power is positive and delivering power is negative. So since this voltage source is delivering power, I will take it as negative. Whereas this voltage source, it is absorbing power. So I will take it as positive.
Positive.
Yes. In the same way, if there is a current source, I, which is delivering the current I, and the voltage across it is V. What is it doing? Is it delivering power or absorbing power?
I'm delivering.
Delivering.
So totally negative.
Negative.
Yes,
In
negative.
the same way, what about this I? See the sign of the voltage and the current. Is it delivering power or absorbing power?
Observing, ma'am.
Observing. Absorbing.
Absorbing, ma'am, from voltage source.
Yeah.
So it will be
these are the
positive.
four. Yes. If it is a resistor, what is this doing?
It is absorbing the power.
Yes, it's also absorbing the power.
Positive.
If it is a capacitor, what is this doing?
It also
Absorbing
absorbs
the
the current.
positive.
If the current enters the positive terminal, then it is if the
Positive.
current enters the positive terminal of the element,
Okay.
what does it say? See, here the current is entering the positive terminal, right? Here also the current is entering the positive terminal. We call it as absorbing.
Yes.
And if the current is entering the negative terminal, like here, see, I is flowing this way, then we call it as delivering power. This is just to simply identify whether it is delivering or absorbing. Now we'll come to the VI characteristics. What is Ohm's law?
V is equals to I.
Equal IR.
That is, there is a resistor R and I am connecting a DC supply V, and this is I and this is R. Now I am telling R is equal to 10 ohms. I am fixing the resistor value and I am giving my voltage as 10 ohms. What is my I value? 10
One.
volts.
V by R. Yes.
1 ampere, right? Now I'm
Yes.
increasing 20 voltage to 20 volts. What is my current?
2 ampere.
2 amperes.
Now 30 volts.
3 ampere.
Now I'm increasing by many folds. 100 volts,
10 ampere.
10 ampere.
10 amperes. Now I'm going to plot it. Okay. My x-axis is I, my y-axis is V.
Yes.
So if I plot this value, I'll get a straight line, right?
Yes, ma'am. With the slope of 10.
Yes. Now if I am giving voltages minus 10 volt, what will be my current? What is minus 10 volt? What is the meaning of that?
Negative
just-
The
voltage.
direction of a current will be changed.
Absorbing the power.
10 volts, but the current in this direction is 1 ampere. So what is the direction of current in this? What is I here? It's minus 1 ampere, right?
Yes.
So again the same graph I am plotting, but for negative. If it is minus 10 volts, it is minus 1 ampere.
Ma'am, can you plot the values in the graph?
Yeah. See, 1 means it will be 10. Here I am writing in terms of 10. It's just a straight line, right? Linear. Now, if I plot this side, it will come like this.
Yes.
Now, are you able to understand why it is a straight line like this?
Yeah, like if we take a 10 volt source, then we get 1 ampere of current. Then yeah, after plotting the
Given,
points, we
yeah,
get a straight line.
yes.
Yeah, okay.
Now tell me what is the slope of this line?
10, ma'am. 10.
R.
Yes.
And
How to find it? B is equal to IR is what we know. We also know the here what is the x-axis. This let it be the x-axis and this is the y-axis. We know this equation is y is equal to mx because this is the equation of a straight line.
yes,
Here what is y? It is b. And what is x? It is I.
I.
So by comparing this and this, I know m is equal to r. The slope is r. Here r I know that is 10 ohms. This
Okay.
is how we will find the slope of a line, right?
Yeah. Ma'am, where did you find the slope? Like you plot that angle.
Ma'am,
Yeah,
ma'am,
that's
also it's of the form y is equal to mx, so we can just simply take from there.
yes. See here the x-axis is so this is x-axis that we are plotting the current. Y-axis
Yeah.
I am plotting the voltage.
Voltage.
This is the resistor or resistance IV characteristics. What is the
Yeah.
equation of this line?
Y is equals to mx.
What is y?
Y is equals to v, and m is equals to I.
X is I. So my
X is
m is v by I. V by
Yes.
I is nothing but r.
R.
This is not the angle. This is the slope representation. Slope representation is r. So we are telling here r is 10 ohms. Now,
Ma'am, how can we take at the one point like the slope?
slope is not taken at the one point. It is like, what is taken at one point? The slope at all the points is 10 ohms only. If you take the slope at here also it is 10. Here also the slope is 10. Here also the slope is 10.
Okay.
If my, for this also my resistor, what is the slope here?
1 by
10.
Is it
1
10?
by 10.
It's 1 by r, 1 by 10. Here the x-axis is v, right? Y-axis is I.
I.
So my equation will become y is equal to mx. Y is nothing but I. M. X is v. M is equal to I by v. I by v is nothing but 1 by r.
Yes.
So don't
Yes.
get confused. Please look what is the x-axis and what is the y-axis. Then write the slope. Okay.
Okay.
Yeah. So in the lecture, what was mentioned is, see, for positive I value, for positive V value, this quadrant, V into I. What is VI? That is power, right?
Yes.
So that is positive.
Yeah.
That is the resistor in the first quadrant is absorbing power.
And
In
third
first quadrant,
quadrant,
the resistor is absorbing power,
negative.
right?
Yes.
Not negative, it is positive.
In third quadrant, ma'am.
In third quadrant also, V is also negative. My I is also negative. So minus Y into minus I. So that is just VI.
Plus.
So my power
Yeah.
is positive. So
Positive.
in
Yes.
third quadrant also, resistor is absorbing power.
Okay.
So that's what they are mentioned in the lecture. Is it clear now?
Yes,
So in
ma'am.
first quadrant and third quadrant only, VI characteristics of resistor is present. In both these quadrants, the power is positive, so it is absorbing power. Is it clear?
Absorbing. Yeah. And remaining both quadrants are delivering the power.
Yes. That's why if I draw the IV characteristics of a current source, if I say I, V, how will be my IV characteristics be? Will it be parallel to the x-axis or y-axis?
Current source delivering the power. So
No,
Yeah.
tell me how the graph will be. Will it be parallel to x-axis or y-axis?
y-axis.
Draw the IV, it will be parallel to the y-axis, right?
Yes.
This is the IV characteristics of the current source. If this intersection point is A, what is the equation of this line?
X is equal to 5.
X is equal
X is equal to 5. So that is I is equal to 5, right?
Yes.
That means whatever the voltage, my current will always be the same. That is the characteristics of an ideal current source, right? Whatever the voltage is delivered, the current, okay, whatever the voltage across it, the current delivered will be constant. That is a current source, right?
Yes.
Okay.
Constant
Now if
current
you
source,
see,
but voltage is 0, na ma'am, here?
the voltage is not 0, right? Voltage is varying from here to here, but the current is
Yeah.
same. It is 5.
Okay.
Okay. Now this current source is present in first quadrant and fourth quadrant. So in first quadrant, it is absorbing power. Whereas in the fourth current quadrant, it is delivering power. So the current source can either absorb or deliver power, right? Depending on the configuration.
Yes.
Now tell me VA characteristics of voltage source. We'll complete that also. Is it parallel to x-axis or y-axis? Okay, let me write which is V and which is I. Now tell me. is
No, I
voltage-
think it will be parallel to I-axis.
Parallel to the I-axis.
X-axis.
The equation of this line
V is equal to 5.
V
5.
is equal to 5. It is
Constant
present
voltage.
in first quadrant and second quadrant. In first quadrant, is it absorbing power or delivering power?
absorbing.
Absorbing.
Yes. In the first quadrant, it is absorbing power. In the second quadrant,
Delivering the power.
delivering. Because in the second quadrant, the V is positive and the I is negative. V into minus I is a negative value. So it is
Delivering the
a
power.
delivering power.
Yes, ma'am. I understand.
Yeah. Okay. So let me give you a simple circuit. 5 volt. This is 2 ampere. Sorry, 2 ohms, right? This is a resistor since the resistance is 2 ohms. What is I value here?
2.5.
Yes, V by R, that is 2.5 amperes.
Yes.
Yeah. What is this voltage source doing? Is it delivering power or find the power delivered by the voltage source? This is my first question. Next question. Find the power absorbed by the resistor.
Ma'am, current is 2.5 ampere.
Yes, 5 divided by 2, right? Then we are going to find power delivered by the resistor.
Ma'am, power delivered will be 12.5
12.5, yes, ma'am.
watt.
Because V square by R.
Minus
And it's 10 IV.
When we using the
Okay.
voltage, using the voltage source.
Yes, first we are going to find the power delivered by the voltage source, right? Is this voltage source delivering power?
Yes, ma'am.
yes, ma'am, yes.
So
Negative.
I will write it as positive. Because in the question you have to see, if they are asking delivering power, it is positive.
Delivery is positive, like
Yeah, okay. That's like you also have to see the question. If they have asked power observed, okay, wait, let me write all the 4 questions. So usually observed, we take it as negative, sorry, positive, and delivered, we take it as negative, right?
yes, ma'am.
Okay.
This we are keeping this as reference. Okay, but here in the question, if they are asking power delivered by the voltage source, then we will write the answer with respect to the question. Is it clear? Or is it confusing?
It is confusing, na ma'am. How can
This is like usual convention. Normally, if we are going to write a big problem and solve it, we will take, for our convention, we will take the observed power as positive and delivered power as negative. This is according to our convention, okay?
okay?
But if they ask power delivered, and if you write negative, so it actually means that is the power is observed. We have to write here with respect to the question.
Okay. And if there is
So-
not given that absorb or delivered, then we had taken that
Yes.
absorb is positive and delivered
Exactly.
is negative.
Yes.
Then we go for the standard directions.
Yes, these are standard convention. But we also have to answer with respect to the question. Here they have asked power delivered by the voltage source. So delivered is the voltage source delivering the power? Yes. So I will write
Yes.
it as positive because if
Ma'am, for
suppose if I
example,
write this,
if they didn't mention delivered, then we will
Yes.
write minus to verify that it is delivered actually.
yes, right.
It will be verified, I think, by the direction of the standard directions. If it is a negative before the magnitude, it means it delivered something, and if the positive, then it may observe something. If the question is
Yes.
not mentioned about the anything delivered or observed.
I hope by answering all these 4 questions, you will be clear with this concept. You just tell me, power delivered by the voltage source, what is the sign and what is the magnitude?
12.5.
It's plus 12.5, right?
Yes.
The power absorbed by the resistor
Minus
is the power
12.5.
absorbed by the resistor? No, the power is
Minus-
absorbed by the resistor, no? So it's still plus 12.5 volts.
Okay.
What is the power delivered by the resistor?
Minus 12.5.
It is minus 12.5.
Yes.
Yes.
What is the power absorbed by the voltage source?
Minus 12.5.
Yes, minus 12.
So these are the 4 questions you will answer with respect to the question. Okay?
Okay.
So see, if they are asking this question, power delivered by the voltage source, you will first identify the voltage source, then you will identify whether it is delivering or observing. If it is delivering, in the question also if they are asked delivered, then you will write positive. But if this voltage source is observing power, but in the question if they are asked delivered, then you will put it as negative. Right? Yeah, I
Again,
give
it
you around
feels
3
little
minutes.
bit confusing, ma'am. Delivering absorb.
Yeah. Please go through these 4 questions. Understand
Okay.
it. If you have any doubt why they are writing it as positive or negative, if you have any doubts, ask me.
Okay.
Now I understood, ma'am. Like in third question, it is asking power delivered by the resistor, but actually
Yes.
resistor is absorbing the power, so it will be negative.
Yes, right.
Basically.
Yeah.
Okay. So negative
What it is
verifies
actually
that
doing-
it is actually absorbing the power.
Yes, it is opposite of what is given in there. So it is negative. Okay?
Okay, ma'am.
Yeah. I'll wait for around 2 minutes or everyone, all the others also able to understand, right? If you are having doubt, please ask. Because this will be confusing. In the lecture also, they would have said observed power, we should take it as positive and delivered power is negative. But in the practice assignment and graded assignment, it will be little confusing. So, please ask if you have any doubts.
Like if there is a contradiction between the statement or the language of the question and the actual scenario which is happening on the circuit, then it will be negative sign when the contradiction
Yes.
is at this. But both the statements
Yes.
align with the same direction, then we will consider the positive sign.
Yes. So you should know whether a certain element is observing or delivering power.
Can you explain the second one again?
The power absorbed by the resistor, right?
Yes, ma'am.
See, resistors usually absorb power. Right?
Yes, ma'am.
So also absorb power, we are taking it as positive convention. So we are putting it as plus 12.5.
Okay, ma'am.
In the third question, if you see, they are asking the power delivered by the resistor. But resistors actually absorb power. So we are putting it as minus 12.5 to represent it. Oh, sorry. Actually, power unit is watts, right?
Yes.
Yes. So in the question they asked delivered, but it is actually observing. So to show that I am putting minus 12.5 to indicate the resistor is not delivering power, but it is absorbing power.
Yeah, in fourth one, we know that the resistors is always absorb the power, and there is only one component in that circuit, and we know that resistors always absorb. There, that means the voltage source is delivering to the that, and voltage source is absorbing from the negative terminal, like
Yes.
a current. Using the energy
So shall
conservation.
we move to yes. Shall we move to the next topic? Is
Yes.
all your doubts clear?
Yes.
Okay.
Yes, ma'am.
Yeah. Yeah, tell me what is the answer?
10 watts.
Sign?
Huh?
Yes, ma'am.
Is the sign positive or negative?
Positive.
Yeah.
Absorb the current. Yes.
Because the current is going through it, entering the positive terminal, so it is absorbing the current, absorbing the power. So yeah, no doubts, right?
Ma'am, if the current would have been in opposite direction, so then
Yeah, using
we
that
would
our
say
Yeah.
standard
If my current,
standard sign convention, power delivered,
if it is like this,
absorbed means positive.
tell me here. What is the answer here?
Minus 10, ma'am. Minus 10.
Yeah. Clear, right? No doubts, right?
Power absorbed. Yes.
Shall we move to the next
what
topic?
we can.
Yes, ma'am.
Yes.
Yeah. So these type of questions will be little confusing, but please understand it. See the questions carefully and then answer. Okay.
Yes.
You can actually there are like many questions in practice assignments also. So if you solve those, you will be more clear. The next one says.
Ma'am, in the activity and practice assignment solutions are not like uploaded properly.
Not uploaded properly.
Yeah, even GA as well, it's just till week 2.
Okay, yeah. Okay, it will be uploaded soon.
Okay.
So next what we are going to see is RC step response. Okay, let me see. This is my V in. This is my R1 and this is R2. What is the voltage here?
I mean, it's lagging in.
Is my voice audible now?
Voice is
Your
audible,
voice is
ma'am,
good. Screen is
but screen is lagging.
Okay. Now?
No.
not
Not
ma'am.
So what is my V naught of T?
Ma'am, I think stuck.
We can't say anything here. Only
Okay.
we can say that RC step response written.
Okay, 1 second. I will stop sharing and then I will share it again.
Yeah, now we
tell
can
me.
see that.
Yes, ma'am.
Yes, ma'am.
It is.
Yeah.
What? So there is a input voltage. R1 and R2 are connected in series with that. And I want to know the voltage across R2. What is the formula for that?
We use
R2 by
voltage divider.
R1 plus R2 into V.
Yeah, it's a voltage divider. So
Into
R2 by R1 plus R2
V.
into V,
V.
right?
Yes.
In the same way, now we are going to find if the circuit is like this. There is a R and there is a capacitor. Instead of the R2, there is a capacitor, and we are going to find the voltage across the capacitor. This we call it as RC step. Finding VC of t, we call it as RC step response. Okay. So we are going to actually derive the equation for VC of t. So why we are learning this RC step responses, in the next week, that is week 7, you will be learning about filters. Okay.
Yeah. High pass,
Filters
low
means,
pass, and band pass.
yes, high pass filter, low pass filter, and comparing these both, you will learn band pass filter. Low pass filter is nothing but a resistor like this. This is low pass filter, and high pass filter is capacitor like this.
Okay. Capacitor is directly connected to the positive terminal.
No,
And
the across which you take the voltage. If you take the voltage across VC of t, it is a low pass filter. If you take the
Okay.
voltage across resistor, that it's a high pass filter. So in order to understand this, you have to know the voltage drop across the capacitor and all. No, so that's why the last lecture of here is a RC step response. So this is the reason why you're going to learn this RC step response video. Okay, so you will have a derivation under this. So simply we'll just derive what is value of VC of t. I will just go through the derivation. After saying this, if you go through the video also, it will be more clear to you. Okay.
Ma'am, sorry, what are we doing? Like, I just missed that.
So what I'm saying is, so basically in this week we saw power conventions, amplifiers, and the reason why we are going to see RC step responses in the next week, that is week 7, you will be learning about filters, that is low pass filter and high pass filter, and these filters will have this RC components. So before learning that RC components, you should be able to know how to derive the equation when there are C components, capacitor elements. So for that, we are learning the basics in this lecture, that is RC step response.
Okay.
So that's okay. So that's the reason why we are learning this one. Because
So ma'am,
it
we will
see-
apply KVL, na?
Yeah, it will apply KVL. So you shouldn't feel it is like a little different concept. That's why I'm telling you why we are learning this. Okay.
Okay.
Okay, ma'am.
So yes, I is the current flowing through that. If we apply KVL, what is KVL? In a closed
Kirchhoff
loop,
Kirchhoff
increase is equal to voltage drop, right?
Yes.
So V of t is equal to VR of t plus VC of t. Now, what is the formula for capacitance?
Q is equals to CV.
Q equals CV. So ma'am, from that we will write V equals C upon Q.
Yes.
No, dq by dt is equal to C dV by dt. So I is equal to C dV by dt, right?
dq by dt. Yes.
So, okay, this is one formula that we know. And also, this capacitor, I will assume, initially it is charged at 0. Capacitor can store energy, right? So, in this we are assuming that initially the charge stored in the capacitor is 0. The voltage across it is 0.
Ma'am,
That I'm going to
in that
calculate.
formula, I is equals to C dV by dt. At C, ma'am, this is C side of V.
That is the subpart. That is like subscript. That is the voltage across the capacitor.
Okay, okay.
That is voltage only. Since it is across the capacitor, I am using that small c to represent that.
Because
it is
I know that C dV by dt, but when I saw that C, then
okay.
I.
Yeah. So, voltage across the resistor, we know Ohm's law, right? So I into R plus VC
Yes.
of t. The I is the same current that flows through the resistor and capacitor. So instead of this I will apply this formula. So V in of t is equal to C dVc by dt into R plus Vc of t. Okay. So reformatting RC dVc by dt plus Vc of t plus minus V in of t is equal to 0. Now this input I am assuming it as unit step response. What is unit step input? That is nothing but a signal which is like this, u of t. Have you heard of this term u of t? Unit step input.
Yeah, I saw in the video lectures, but what is the U here, ma'am?
Okay,
You-
u of t is just a representation. That is a signal. Only it has values only in the positive side. From only the positive time signal, you will have value as 5 volts. Whereas in the negative side, it will be 0. That type of signal we call it as unit step input. Okay.
Okay,
So
only
there
in
are
a
various
positive
type of
way.
inputs. Yes, this is one among them. So basically, there are
Okay.
different type of signal. If there is a signal only at 0, if it has value, then we call it a delta of t. It's a delta function. Then only in the positive side, if you have, it is u of t. If it is linearly increasing, then we call it has separate name. So there are different types of signal. Each signal has a name. This is one among them. That is unit step. That means in negative it has 0, in positive it has some value.
Okay.
Is it clear? Okay.
Yes, ma'am.
Yeah.
Can you
So
again
now
tell that
we are
until
going to
step input?
okay. See, this is okay. You have heard of sine wave, right?
Yes.
Yes, ma'am.
This is also one such signal. The input can be any type of signal. It can be like this, or it can be like this, or it can be a sine signal. So this is one such type of signal. You represent it as u of t. And what is the function is, for negative values of the x-axis, the value will be 0. And in the
0.
positive side, it will be some value like 5 volts or 10 volts or 2 volts. Such type of signal, we call it as u of t. Okay?
Okay, ma'am.
Yeah. So we are going to solve this signal, this equation, but it has a derivative term. So what do we call this equation? It's a differential equation,
Basically,
right?
ma'am, basically we are solving a DC source.
Yes. DC source, but it is only for positive t. My goal is to solve for Vc of t. And my equation is Rc dVc by dt plus Vc of t minus Vin of t. This is in the format A dy by dt plus by plus c equal to 0, right? This is a constant, right? And this is y. This is y. A is this one, B is 1. Right? Is it clear? So this is a differential equation. Now, if it is dy by dx is equal to f of x, what is y? This is simple differential equation, right? Y is equal to integral of f of x, right? You guys know this, right?
Yes.
Yeah. Now we are going to solve this type of equation. Rc dVc by dt plus Vc minus Vin equal to 0. And Vc is a function of time. Now, this I will divide everything with Rc. This is my second step. So VC by RC by V in by RC. Now 1 by RC, I will take it as P of T, and V in by RC, I will take it as Q of T. I am just substituting. So dVC by dt plus P of T, Vc of T is equal to Q of T. Right? Do anyone have any doubt in this equation?
Yeah.
Now, to simplify, I am multiplying with e power integral P dt. So dVC by dt integral P dt plus P of T integral P dt Vc of T is equal to e P dt Q of T.
Man, this is a derivation, actually.
Yeah, this is a derivation. You are going to
Ma'am,
find
we
Vc of T.
We had to use that derivation to solve that questions, or we will get some formula.
Formula. We are going to find a formula for Vc of T.
Okay.
Because
And
we
we
have to
will
find
use
the
that
voltage across the
formula,
capacitor.
and we can find our answer easily.
Yes.
Okay.
We
Because
can't
I had
directly
a
find solve the
problem with
differential
that.
equation.
Yeah, maths ma'am, I did not do that. I can't do that kind of equation and derivation.
Yeah. Here you have to just understand how we are going to derive it.
How
Okay.
we get that
You
formula?
don't have to by heart it. Now I'm going to take only this first term. D by dt of Vc of T into e power integral P dt. Okay. This is U and V. What is UV? The whole dash?
A step input voltage.
No. UV, this is a formula, right? Integration by part. UV, the whole differential is equal to UV dash plus U dash V. You guys remember this formula, right?
Yes, ma'am. Chain.
Yes. That we're going to apply here. Yeah, chain rule. This I will take it as U and this I will take it as V. And now I'm going to differentiate it. So first I will keep Vc of T as such and I'm going to differentiate this. So it will remain the same. Then this will say d by dt Vc of T. Do anyone have any doubt in this step?
No, ma'am. It's good.
So I am differentiating, keeping Vc of T as such, then I am differentiating V. D by dx of e power ax is e power ax same, then dA by dt. D by dx. So this is the formula I have applied here. Then V I have kept as such, then I have differentiated the U, that is dVc by dt. Now, what is this value? There is a differentiation and integral term. That two will get cancelled, so it is just P. Right?
Yes, ma'am.
Vc of T e power integral P dt dot P plus e power P dt dVc of T dt. Now if you see, this is U, this is dV, this is V, this is du. uv dash plus vu dash is equal to uv the whole dash, right?
Hold.
That I can write it as d by dt e power p dt dot Vc of T, right?
Yes, ma'am.
So this equation, that is 1, and this where we started off are same, right?
Yeah.
So dV by dt, so equal to this value. I will equate with this value. Q of t e power
Ma'am,
pd.
differentiation of e power
Differentiation of
e, like it should be a into e power ax.
e into a power
I think
a.
you just wrote it dA by dx. You wrote it dA by dx, I guess.
Oh, that formula.
Yeah.
Yeah, dA by dx, right? Differentiating with respect to x. This is like not
Got it.
constant.
Got it.
That term will stay same. Then again we'll differentiate that term with dx, right?
Got it.
Ma'am, so will you share this PDF
Yeah.
in GSpace?
Yeah. This will be uploaded in the portal itself.
Okay.
There will be live session slides and the supplementary content, and this will also be uploaded there.
Okay.
So d by dt e power integral p dt dot vc of t equal to q of t e power p dt. Now we know p is equal to 1 by rc, q of t is equal to v in by rc, and my v in is nothing but a step input, so u of t by rc. Now I am going to apply it in the question. And if you apply, okay, so before applying, what we will do is this differentiation I will take it to that side. Everything I will integrate is equal to integral q of t e power integral p dt plus c, right? Then I will apply my pn.
So like basically integration both sides, so differentiation get cancelled on this left hand.
Instead of q, I will write u of t by rc e power integral dt by rc plus c. What is integral dt by rc? Rc 1 by rc is a constant. Integral dt, which is nothing but 1 by rc into t, right?
Yes, ma'am.
Now, so e power t by rc into vc of t is equal to integral u of t by rc into e power t by rc plus c. E power t by rc vc of t. 1 by rc is a constant. I will take it out. U of t is unit step symbol. That is from 0 to infinity it will be 1 e power t by rc into dt plus c. Okay.
Yes, sir. Got it.
Now I will integrate it. Vc of t is equal to 1 by rc. So integration of e power t by rc is just e power t by rc into 1 by rc plus c. This rc and rc will get cancelled. E power t by rc vc of t is equal to e power t by rc plus c. Now we need vc of t, that is 1 plus c e power minus t by rc. So now we have derived the equation for vc of t. It's a little bit long derivation, right?
Ma'am, finally, this is the formula, ma'am.
Yes. Now
Okay.
we also know initially it is 0. Vc of 0 is 0. So I will apply it here. Vc of 0 is equal to 1 plus c e power 0. E power 0 is 1. So C is equal to minus 1. We got the value of C, that also will apply here. Vc of t is equal to 1 minus e power minus t by rc. So when my V in is a unit step input, my Vc of t is equal to 1 minus e power minus t by rc. This is unit step input. Vc of t is a unit step response.
Ma'am, what is meant by unit step input? When the
That I said
graph.
no. This one. This will always be 1.
Okay.
Unit means 1. Step means it is a step signal. It changes at 0. And positive side it will be always 1. That is a unit step input.
It can't be
I mean,
greater than 1.
T. This is the voltage. Okay.
Ma'am, it can be
So, ma'am,
greater than 1
value
or
of-
not.
See, if it is greater than 1, my signal will become Vc of t, and if this u of t is some Vm, Vm 1 minus e power minus t by rc.
So ma'am,
Ma'am,
V
here we
input will
do-
always be 1.
No, if it is a unit step input, it will be 1. If it is just a step input, it can have some value, like some Vm or Vn.
Yeah, given
Okay.
value of 5, 6, 7, 8. Okay.
Unit means 1. So if it is a unit step, it will always be 1.
Okay.
ma'am, means what we have got here it has a very limited use because we have used a constraint that is u of t, a unit step.
Yes. So my constraint is Vin is equal to u of t, unit step input. Then also, I also assume at times t c is equal to 0, the voltage is 0. Under these two conditions, my Vc of t is equal to 1 minus e power minus t by rc. If my Vin is equal to some Vm u of t, my Vc of t will be Vm also. Under these two conditions, Vm of 1 minus e power minus t by rc. These are the formulas and the conditions you have to remember. Okay.
Yeah.
Under
Okay.
these two conditions only you can apply this formula, and under these two conditions you have to use this formula. Is it right?
Ma'am, can you give a
Yes, ma'am.
number like when we use that and when we use that, when we write that, we see that PDF, it will be helpful.
See, if I am saying this is a step input u of t,
Okay.
and there is a capacitor connected, if the circuit is like this, and they have also given another condition that the capacitor at 0 is 0. The voltage across the capacitor at time t is equal to 0 is 0, and the unit step in the input is
1.
like this. Then the voltage Vc of t is equal to 1 minus e power minus t by rc. Okay,
Okay.
this is my first equation. Okay,
Okay, ma'am.
now this is not 1, it is Vm u of t, t signal rc. Also Vc of 0 is equal to 0. What is the equation now? It will be this Vm will be multiplied.
Okay.
Okay,
Okay.
right?
VM multiplies when it is not an input, step input,
Yes.
unit step. If it is not unit
Yes.
step.
Only when u of t and this both, you can use this equation. If the input is a sine wave, this you cannot use.
Okay.
The second one is, ma'am, general equation for all the values.
Yes, generalized. Yes.
What is about sine wave, ma'am? Can you, if input is
Sine
sine
wave you
wave,
will learn in week 7.
Right.
In week 7 summary, you will
now
see
you
that.
told now if input is sine wave, then
You cannot use this formula. You have to derive it again.
okay.
So
And ma'am, in whole expression we did now and derivation, we only
Yes.
to find that formula. How the scientist got that formula? For that, ma'am.
yeah, we derived it because we wanted to know when I give a unit step input as I to your RC component, how my BC of t is.
Can you tell me what topic I need to do practice in mathematics to drive like that formulas and that thing? Because I
See, in
did.
lecture itself, see, in this week they would have derived for u of t. In the upcoming series, they would have derived for sine wave and cos wave. So it's enough.
Okay.
So
So
watching the
which
lecture
topic
is enough.
on mathematics, ma'am, to derive that function? Because I did one mistake that now I realize that I skipped that functions derivation and integration. I did not give that so much important because I am
So
good
you
in
didn't.
physics, but I did not good in maths. This is my weakness.
So you skipped few topics in maths. So you wanted to know what are the topics you want to learn for
Yes,
further.
ma'am. Yes.
Uh, currently, you are having any math course?
Ma'am,
No, ma'am.
the
I cleared my mathematics in a passing in first term.
Anyway, you will be going through like differentiation, integration that are useful. You can just go through the how they are like basic differentiation and integration rules. You can go through that.
Okay.
So there will be some formulas.
Yeah,
You don't
ma'am.
have to
Due
memorize
to this,
it.
I lose so many things, ma'am. In JEE mains also, I got 50 percentile in physics and 75% in a percent in a chemistry, but only 6 to 8% in a mathematics. That's why my percentile is too much low to mathematics.
Actually, then you don't have to you don't have to learn maths like you have to learn it. You can just go through it.
Okay.
Just understand concepts. Like you can take any math book, just go through it. But from this course point of view, knowing the basics of integration and differentiation is enough. Because
Okay.
anyway, I will be teaching basic rules like what is the differentiation of like whenever there is some differentiation, I will like teach you the formula also. So from this course
Okay.
point of view, knowing basic integration and differentiation is enough.
Okay.
Till now, do anyone have any doubt?
Ma'am, I have a doubt here.
Yes.
Ma'am, I have just completed the qualified quiz one, ma'am, successfully.
Okay.
And I have also registered for the foundation course,
Okay.
including ESTC lab session.
So you want to ask doubt related to lab session.
Yeah.
So are you in the G space?
No, ma'am, only now only I joined foundation level.
Okay. So then
From
you can mail the support team. Have you tried mailing support team about your doubts?
Okay, ma'am.
Yeah.
When
Please
it
mail
will be held?
labs.
Lab class, when it is held?
When
Yeah, it will
this
be
term
informed.
ends after December, in January you will
Yes,
get that.
after it will be, mostly in January first week.
For how many days
So
shall I
anyway,
give that?
Only 2 to 3 days. No.
Oh,
yeah, you will be getting announcement and mail regarding that. So and if you have any doubts, please mail support team.
okay, ma'am. Thank you, ma'am.
Yeah. But till now, do anyone have any doubt?
No, ma'am.
Not in that, ma'am. I had doubt in that graded assignment week 5, question number 9.
Week 5 graded assignment.
Yeah.
Question number 9.
9. Only the resistance value is given, ma'am, not the voltage and no current given. Then how to find? I do not understand.
Okay. Actually, for this question, you have to use the formula.
Okay.
Wait, let me copy paste the question.
Okay.
So, see, it is like this, no? For this, there is a direct formula also. That is 1 by R1 V1 by 1 by R plus 1 by R1 plus taking this is R, this is R1, this is R2, this is R3, and this is
R4.
R4.
Yeah.
1
Ma'am,
by
now the
R2
V6
plus 1
number
by
is 20.
R3 plus 1 by R4.
Yes.
Ma'am, V6
Have you guys
number is
seen
completed.
any formula like this?
Yeah, ma'am. For the superposition method.
Yes. So Vx is equal to 1 by R1 divided by 1 by R plus 1 by R1 plus 1 by R2, that denominator value. This I'll take it as D.
Yes.
Ma'am,
So 1 by R1 V1 plus 1 by R2 divided by D into V2, 1 by R3 divided by D into V3 plus 1 by R4
Okay.
divided by D into V4. So the question they are given the format, like A is the numerical value of V1. So this is A. So to find A, you don't need these values, like V1, V2, V3, V4. You just need R1, R2, R3, R4, and R value. And you have those values.
Okay.
Now you can find, right?
Can you find across the 80 ohm?
Yeah, you can just find 1 by R1. 1 by R1 is 1 by 80 divided by
Yes.
1 by R is 1 by 100 divided by 1 by 80 plus 1 by 40 plus 1 by 20 plus 1 by 10. Solve it and tell me what you're getting.
Okay, ma'am. We had to find with the help of that formula only. I did not
Yes.
saw any voltage value of voltage sources and current sources. I leave that question. I don't understand that what.
Okay.
How, okay. Okay. Ma'am.
You have to use this formula. See,
Okay.
okay. Because in circuits, no, you can use any formula to find the solution for any circuits. In order to make you realize the importance of this formula, only this question has been given. So you have
Okay.
to remember this formula to solve this. That's the scope of this
Okay,
question.
ma'am.
That's why V1, V2, V3 is not given. So that you can understand the importance of this formula.
Okay, ma'am.
Yeah.
Thank you.
thank you, ma'am.
Yeah. Yes. Shall we leave this now?
Yes, ma'am.
Yeah, thank you.